overdoses in the state of Connecticut and nationally by Charles Callahan and George Suarez. CS2316, Professor Aaron Hansen. Point of interest and purpose. The opioid epidemic is a major issue in local communities and in the public eye, with much of the blame, rightfully, being placed on the pharmaceutical companies in the overprescription of these drugs. We want to see if certain demographics are disproportionately affected by fatal opioid overdoses. We also want to do a case study comparing the state of Connecticut to the national average by state for opioid prescription and overdose death statistics. We believe that Connecticut will be around the national average. Finally, we hypothesize that the fatal opioid overdoses will be directly correlated to the number of opioid prescriptions.
Data acquisition. So we use the data.gov catalog to acquire our downloaded data set, our second web requirement, which is a JSON file, and our additional data set. And then we acquired our first web requirement, which was HTML from the CDC's website. Data cleaning. So our data inconsistencies were the following. In the downloaded dataset, we found ambiguity in the race column where multiple labels refer to the same demographic, specifically using both Black or African American and just Black, which would make using the group by function extremely difficult. And we address this by indexing every row with the string Black or African American and simplifying it to the string Black. In the downloaded dataset, the format of the dates was a string in month, day, year format instead of just the year like in our other datasets. Once again, this will make group by extremely difficult, and we handled it by creating a list of all the dates split on the slash, and we then iterated through that list and create a list of the years as integers, which would then become the new values in the date column. In the additional data set, there were NaN values in many rows of the estimate column, which was significant because any row with a NaN value in that column would not be useful for any statistical analysis, and we handled it by removing every row with a NaN value in its estimate column. Then finally, in the downloaded data set, the any opioid column only contained empty strings or the string Y, which would make it difficult to perform math functions with this data. We handled it by replacing every instance of an empty string with the integer 0 and every instance of y with the integer 1, which will make performing math functions on this dataset much easier. After that, we also removed any columns from our datasets containing data that we found to be irrelevant to our analysis. Here is the code for our cleaning of our download dataset. Here's the code for cleaning our web collection requirement, our first web collection requirement. And then here's the code for cleaning our web collection requirement number 2. And then here is the code for cleaning our additional data set.
For our first insight, we analyzed the percentage of fatal opioid overdoses broken down by sex nationally and by sex and race in Connecticut. In Connecticut, white people made up the highest percentage of opioid overdose deaths, though it's important to note that there weren't total statistics given for demographics for the entire state. Therefore, we weren't able to draw a conclusion based off of a certain demographic being more prone to opioid overdoses compared to another. Both nationally and in Connecticut, males make up a disproportionately high percentage of overdose deaths, with a 75% percentage of overdoses in Connecticut, as well as 67% of overdoses nationally. This was our code for our first insight. This was our code for our visualization 1, visualization 6, and visualization 7 based off of overdoses based on race percentage, as well as percentage of males and females overdoses within the national level as well as in the state of Connecticut.
For our second insight, we first analyzed the annual average amount of fatal opioid overdoses in Connecticut, as well as on the national level for the state average. So nationally, the U.S. averages over 17,000 fatal opioid overdoses a year per state. And in Connecticut, it only averaged 627 fatal opioid overdoses a year for the years we looked at. Um, and then we also analyzed which year had the peak amount of fatal opioid overdoses for both the U.S. per state and Connecticut. And the highest year for the U.S. per state was 2017 with over 29,000 fatal overdoses, and the highest year for Connecticut was 2021 with over 1,400 fatal overdoses. In both cases, we concluded that Connecticut was well below average for the number of fatal overdoses per year. And then here's our code for our insight 2.
For our third insight, we analyzed the percentage of total overdoses per year were opioid related at the national level as well as for the state of Connecticut. At the national level, the percent of fatal overdoses that were opioid related initially dropped in 2007, but then steadily increased to their original level by 2017. In most years for the state of Connecticut, opioids were involved in 90% or higher of the total percent of fatal drug overdoses in Connecticut, leading us to conclude that opioids were involved in the majority of drug overdoses nationally as well as in Connecticut. This was our code for our third insight, and this was our code for our visualization 4 and visualization 5. For our fourth insight, we analyzed the percent difference between national annual average amount of opioid prescriptions and the average annual amount of opioid prescriptions in Connecticut. Connecticut has always been below the average but has steadily approached the national average since 2014, with 46% less prescriptions in 2014 and 37% less prescriptions in 2020. This was our code for our fourth insight.
For our fifth insight, we analyzed the amount of opioid deaths, the amount of opioid prescriptions, and the opioid fatal overdoses per prescription in Connecticut. So we found that although the amount of opioid prescriptions steadily decreased in Connecticut, which can be seen in the line graph to the right, the amount of fatal opioid overdoses, which can be seen in the bar graph, and deaths per prescription, which can be seen in the rightmost column, the table below, both increased. So this led us to reject our initial hypothesis of the number of fatal opioid overdoses being directly correlated to the number of prescriptions. So instead, there's probably a larger combinations of factors that would more directly indicate increases and decreases in overdose deaths. And this is our code for Insight 5. And this is our code for our 2 data visualizations. Our conclusion. So the only demographic we could definitively conclude to be disproportionately affected by opioid overdose deaths were males on both the national and state level in Connecticut. We also concluded that Connecticut was a below average state for opioid prescriptions and overdose deaths, but the percentage of fatal overdoses being opioid related was generally higher than the rest of the nation. Also state on that the media hype is real, as we saw that opioids make up generally a majority of overdose deaths both nationally and in Connecticut. And then when analyzing Connecticut, we disproved our initial hypothesis of the number of fatal opioid overdoses being directly correlated to the number of opioid prescriptions. We learned to merge data frames based on shared values rather than concatenating and then splicing initial data sets to split up complicated sets. We did that by using the merge module. We also learned how to use the built-in plotly module for more complicated plot formatting. Our greatest challenge was learning how to effectively use our extra source CSV, as it had the majority of the national data, but the data set was not organized by demographic, but rather just spliced demographics one after another, making group by for the data frame extremely challenging. It was also difficult to find data sets with the requisite amount of inconsistencies, which more so speaks for the improvement in data science and data collection over recent years.